Hello,
Good evening, sir.
audible? Am I audible to you?
Yes, sir.
Okay, good evening. So the topic is electric current and its effects. Okay, have you gone through this chapter once?
Yes, sir. Once I have gone through this chapter.
Okay, can you define electric current?
Yes, sir. Sir, can you wait a minute, sir?
Okay,
Sir, electric currents are currents that we make from water or coal and that run in our houses through AC current, DC current or AC current. That I have a confusion, sir. Uh, uh, Electric current helps us in our daily life, and it's used mostly in our homes for this much only, sir.
I just wanted the definition, a single statement. Nimisha, can you define?
The flow of electricity through a conductor is called electric current.
Okay, the flow of electricity through a conductor. Okay, suppose this is a conductor or conducting element, है ना? Flow of electricity. For that to happen, there should be plus and minus terminals in the circuit. Okay, so the definition is very simple. First of all, after that you can write a passage on it. Okay, Naman?
Okay, sir.
Electric current is the flow of electricity through a conductor, okay, or a conducting material, like you can tell in like copper, aluminum, whatever it may be. Okay,
Okay, sir.
now electric current definition we have taken. Now you have heard about electric cell.
Yes, sir.
Electric cell, what it is?
So, when a large amount of current passes through an appliance, when the wires get overheated, the appliance gets damaged. To counter such situations, a safety device known as electrical fuse. Sir.
Electrical fuse you are talking about. I am talking about electrical cell.
I don't know about the cell,
Nimisha,
sir.
are you aware?
Yes,
What is electric cell?
electric cell is a device which is used to obtain electricity and it is safe to perform science experiments.
Okay, is there any difference between electric cell and a battery?
Yeah,
What?
battery is always used in pairs whereas cell is always used as a single.
Okay, electric cell is used in single. Okay, we have seen a battery in our house also. Normal battery 1.5 volt. This way 1.5 volt. I'm writing here. It is given as plus, and the next terminal is written as minus. Have you seen that practically, Naman? Anywhere in your house?
Yes, sir.
In the torch also we are
Yes,
using
sir.
basic electric cell, isn't it?
Yes, sir.
So first of all, we have to understand the basics and conceptual things. Okay, then only we will go for advanced level. Okay, so this is an electric
Okay,
cell. Now we want a battery. Okay, now this is also shown like this. This is plus and this is minus. Okay, this is also a symbol of electric cell. Okay, now battery is a combination of electrical cells. Battery is combination of more than one cells. Okay, combination of cells or electric cells you can write. So suppose this is a battery, plus and minus. Okay, now we can write here the symbol as like this also. Here there are two cells combined for completing an electrical circuit. Okay, now this is plus and this is minus. Now this will be minus and here this will be plus. So whenever the connections are to be done, we have to keep this symbol in mind. Okay, this symbol should be there in mind. How to connect, which one to connect to which one. Okay, like I have shown you plus minus plus minus. This is plus, this is minus, this is plus, this is minus. Now here the cell that we have taken, this cell we have taken. Here there is a plus terminal and minus terminal. Now again here there is a battery which is connected to it. So what symbol will this be? Plus or minus? Which is connected to this end? Minus will be connected to which end to make it a battery? This is
Yes.
cell 1 and this is cell 2, है ना? Yes, plus, है ना? Now this will be minus. Okay, then only this circuit is going to work. Okay, or battery may be used for any practical purpose. Clear?
Yes, sir.
Okay, I am clearing this page now. Now we will be drawing on electrical circuit. Okay, what electrical circuit consists of what elements? Basic electrical circuit. Like there will be a, first of all, power supply. We are taking 1.5 volts, suppose, from a battery. Okay, now there should be a wire also, and there should be a switch also, and there should be an element like resistive element we call it, or you can give a symbol like bulb. Okay, which glows. Suppose we want to glue a bulb here. Okay, so this is also called as resistance or resistive element. Resistance, or you can write it as resistive element or component. Okay, component. What is this? This is a switch. Okay, Naman, is it clear to you?
Yes, sir.
Excuse me, sir.
Okay. Ah,
What is the meaning of resistance?
which resists the flow of electricity. Resistance or resistive element or resistive component. Definition will be same. Which resists the flow of electricity. Okay. If we are drawing a circuit like this, okay, is there any practical purpose solved with this circuit? Nothing is being solved now. We want to have any practical use of the circuits. We are using the circuits for some practical purpose, like we have to glow a bulb here, isn't it? In our household, we are seeing now in our house also there are a lot of bulbs glowing. If there is no bulb in the circuit, is there any use of this battery or
No.
cell? No. So there should be a resistive network in this circuit. Whatever item we want to glow, that is a resistive network. Okay, and this glows and our problem is solved. Okay, clear to you, Naman?
Yes, sir.
Yes, sir.
Any doubt in this?
No, sir.
Okay, I'm clearing this page too. Now, symbols of electrical components. Symbols of electrical components. Suppose I am telling you to give a symbol of switch. Okay, then you know the symbol like this. Okay, clear?
Yes, sir.
Now I can tell you to draw a bulb symbol. Okay, now there should be a circular part and there should be a resistance like this. You can draw it like this also. Okay, you can glue it also in this way. Okay, now this is a bulb. Now if you are told to draw a fuse, have you seen fuse practically anywhere in your house?
Yes, sir. One time I saw. One time I have seen.
How
I
it
think
looks
so.
like? Are you aware?
Yes, sir. It's in a glass tube, and it has a. It has two.
This is a transparent portion of fuse, isn't it? And you can see a wire here, thin wire. Have you seen that? And this is,
Yes, sir.
you can say it glass or you can say it as transparent part. Transparent part, okay? And this one is metallic part, okay? Metallic part, silver in color, okay? Now, if this fuse blows off, then you can check it. Why we can't? We can check it because this is transparent. This wire will be broken, okay? We can see that here, this part is broken. That means the fuse has blown off, isn't it? Clear?
Yes, sir.
And bulb also we have taken, switch we have taken fuse. Now we can take battery or cell, okay? And symbol is like this, and you can write like this also, plus minus. Okay, this is also clear. Any doubt in this part?
No, sir.
Should I clear this page?
Yes, sir.
Okay, now we will go to effects of electric current. Effects of electric current. Okay, it has three parts. Whenever electric current is there, then it can have heating effect also, it can have magnetic effect also, and it can have chemical effect also. Okay, first we will write heating effect. Okay, then we can write magnetic effect. And then we will write chemical effect. Now, can you give me practical example of these effects of electric current, like heating effect? An example for that? Naman?
I don't know, sir.
We are using immersion rod in our house,
Yes, sir.
or geyser, you can say, isn't it?
Yes, sir.
If we are using an immersion rod, first there is a connection like this, and here there is a coil like this, okay? And here is the bucket, you can say, of water, okay? Now there will be two wires like this in a plug, okay? Whenever we are giving supply to it, suppose I am writing plus minus here, this is the supply. Whenever supply is there, now the water boils and we take bath in cold season also, isn't it?
Yes, sir.
So this heating element can be of any shape. It can be of simple in construction also, okay? Like this also. There can be coil-like shape also, okay? This is the immersion rod. Now we are also using the press in our home.
Yes, sir.
That is also having the same type of coil inside, okay? In this way. Now magnetic effect,
Electromagnet, sir.
electromagnet. Now have you seen any practical example of magnetic effect?
Magnetic.
Sometimes we are rubbing one, suppose metallic scale on our hair, isn't it?
Yes,
And we
sir.
say that, and we see that it is attracting something, isn't it? So because we
Yes,
are
sir.
also having charges in our body, okay? Now let
Sir,
us take.
I have a doubt, sir.
Okay.
When we rub a scale or a plastic cardboard
Yes.
on our heads,
Yes.
but mostly we call it static electricity, sir.
Yes, that is not electric current. What we are talking. I am
Yes,
just
sir.
giving an example. Now I am drawing the circuit which is having electric current in it. Okay. Now I will showing you.
Okay,
That only
sir.
I am showing. Okay. Now here, suppose there is a. This is a iron part or iron object, okay, in cylindrical shape, iron object, okay. Now here there is a coil, suppose it is of copper, okay, in this way, and we are giving voltage to it, plus minus, okay, supply to it. Whenever now electric current will be flowing from plus to minus in this way, okay. Now whenever electric current flows from, suppose, say we can say A to B, okay, now we observe that this iron object becomes magnetic, okay. So we call it as electromagnet because the magnetic effect is due to the flow of electric current. So the iron behaves as a magnet, and this you can see practically also, experimentally also you can check this happens, okay. Any doubt in this circuit?
Excuse
Yes,
me,
sir.
sir.
Nimisha?
Is electric bell an example of magnetic effect?
Electric bell, yes, that we will discuss after this topic is clear. Naman?
Sir.
Hello? Naman, any doubt? Unmute yourself.
No, sir.
Should I clear this? Is it clear? Now chemical effect,
Yes,
have you
sir.
seen anywhere? Due to electric current,
No, sir.
chemical effect.
I have a doubt in chemical effect, sir.
Okay, tell me.
I don't know what is in chemical effect in electric current, sir.
Okay. Suppose take this example, the first one, heating effect. Okay. Now,
Okay, sir.
whenever immersion rod is used for boiling the water, you may be seeing some salt-like portion left in this bucket. Have you seen that?
Yes, sir.
Is that not a chemical effect?
Yes, sir.
So there are hundreds of examples. Wherever heating effect is there, magnetic effect is there, there is chemical effect too. Okay. Whatever you are,
Okay, sir.
whenever you are passing electric current and whatever may be happening, there is also chemical changes to both the parts. Every part is having a chemical change, either minor or major. Okay.
Okay, sir.
So we have seen three effects of electric current: heating effect, magnetic effect, and chemical effect. Okay. Now first we will
Okay,
move
sir.
to heating effect.
Sir?
Okay, we will start from. Okay, Nimisha, tell.
What is the chemical effect in iron?
In
Iron press.
in iron press.
Yes, sir.
Suppose here there is a press. Okay, let us take it like this. It looks like aeroplane, but let us suppose that it is a press. Okay. Now, when it is heated, then here the surroundings, the air of the surrounding, okay, the hot part of the air will move above that you are aware of.
Yes, sir.
Okay, the cloth which you are pressing, okay, it also turns to very hot. If you are touching it is very hot. Okay, the temperature, the ambient temperature of this area becomes hot. Is
Yes,
that not a chemical change?
yes, yes.
If there is a water droplet here, it becomes water vapor and goes above. Is that not a chemical change?
Yes, sir.
Okay, so there are a lot of chemical changes. Whatever is happening in the surrounding changes. Okay, that all comes under chemical effect. Clear?
Yes, sir.
Should I clear this page?
Yes, sir.
Okay. Now we will move to heating effect first of all. We also say that heat produced is directly proportional to the current flowing through it. Current flowing through it. That means if heat is represented as H, it is directly proportional to I, where I is the current. Clear? If the amount of current passed is more, then the heat will also which is produced will be more. Means heat is directly proportional to current. Clear?
Yes, sir.
Naman?
Yes, sir.
In the same way, heat is also directly proportional to R, where R is I is current, R is resistance. The more the resistance, the heat produced will also be more. Okay?
Okay, sir.
Directly proportional means whenever this left side will increase, it means right side will increase. Whenever right side is increased, left side will also increase. Okay? Now H is also proportional to T, where T is the time for which the current is flown. Okay?
Okay,
And the
sir.
formula for heat is H is equal to I square RT. You can write it in notebook also. In your book, it may not be given, but you have to remember, it will help you in understanding the concepts.
Okay, sir.
Heat produced is equal to square of the current flowing through it multiplied by resistance which it goes through and multiplied by the time duration for which the current is flown through the circuit. Okay, H is equal to I square RT. Clear?
Yes, sir.
Have you written this part in a notebook?
Yes, sir.
Sir. Yes, sir.
Sure, I will check also afterwards.
Sir, what is the name of the what you called H equal to I?
I square RT. H is equal to I square RT. I is the current. flowing through it.
Okay, sir.
And R is the
What's
resistance.
the name of the formula, sir?
Name of the formula. You
Yes,
can
sir.
just write heating effect
Okay,
of
sir.
electric current. That's all. Formula for heating effect of electric current. Okay.
Okay, sir.
Written.
Yes, sir.
I am clearing this page now. Now, can you give me the definition of resistance? Naman?
So resistance is when a thing like when electric current is resisted, then
No,
what
this is not a
when
proper
it's
definition.
resistance.
Try to use your wordings in a standard manner, isn't it? I just
Yes, sir.
told also about 5 minutes back the definition of resistance. Resistance may be defined as the opposition to the flow of electric current.
Okay, sir.
Note it down in your notebook also. Resistance may be defined as the opposition to the flow of electric current in a circuit or in an electrical circuit.
Sir, can you repeat it once again?
Resistance may be defined as the opposition to the flow of electric current in an electrical circuit. Noted?
Yes, sir.
Naman?
Yes, sir. Yes, sir.
Okay. Now we will go to applications of heating effect. Applications of heating effect. When we are passing an electric current through a circuit, heating effect is used or heat is produced. Now this heat when produced can be used in many applications. That's why
Yes,
we are
sir.
doing this all. Now electric current is produced what for? To use practically, isn't it? So how we can apply this heating effect? Where it can be used? Can you think of? Naman?
Yes, sir.
This heating effect is used in our household activities also. Where it is used?
So
I give one definition.
when we are pressing the clothes or when we want the water heated.
Yes, means in heating appliances like heater you are using, room heater.
Yes, sir.
You
Room
can write
heater.
heating appliances, isn't it? Like whatever you remember, you can write, okay, and so on. And then we are using it in bulbs. In bulb also there is a filament. When heated, it glows.
Yes, sir.
This is the glass part, and this is the filament that glows, or the resistive part, isn't it? And then we are also using it in electrical fuse. The fuse that you just described me has a wire, thin wire here, okay? Now
Yes,
this
sir.
wire which is used has a very low melting point. Okay, why we are using it? Whenever there is a sudden increase in electric current which was not expected at all, then this will damage itself, and the circuit which is after this, it may be anything costly, it may be a costly device that you are using in a home. So when the fuse is broken, the circuit is broken, and so the current will not pass through it. If there is this breakage, current can't pass through now, isn't it? There should be a medium
Yes, sir.
to travel. Now whatever circuit you have after this will be safe. This may be a LED bulb, this may be anything, okay, this may be a heater. Otherwise, if there is no fuse used, then it will damage this component. This component will be damaged.
Damaged.
Understood what for we are using electrical fuses?
Sir, why
Yes,
it is
sir.
having low melting point?
Then only it will break now. If it is having low melting point, then only it will break. If it is having high melting point, it will not melt. How it broke? Only because it had very low melting point. Means at very whatever we require, like we want it to break at a certain temperature. By these formulas like H is equal to I square RT, we find out the value, and that's why this is very thin. This should break whenever the current is just increasing from the required amount. We want that the current should be 5 ampere. Suppose it is 6 ampere. Okay. Now this fuse rating is also 5 ampere. Means whenever this is 5.5 ampere, then this will break. This fuse will break. And the device that we are using also needs only 5 ampere. If it is 5.5 ampere, ampere is the unit of
Electricity.
current. Ampere. Okay. This is the unit of current. If it is 5.5 ampere, this component will be damaged. So to avoid such damages, we are using fuses here. Okay, otherwise the circuit will work without fuse also. But fuse is a safety device, isn't it? We can write here safety device or safety element. For safety, we are using this fuse. Safety device. Are you getting?
Yes, sir.
Naman, got it?
Yes, sir.
Should I clear this page now?
Yes, sir.
Okay. Now we were using bulbs first of all, the old type ones, and now we are using CFL, isn't it?
What CFL, sir?
This is called as compact fluorescent lamps. Write it down. Compact fluorescent lamps. Fluorescent lamps or lamp. CFL, the white bulbs that you are using at home presently, or tube lights. Okay. And before we were having yellowish type of bulbs. Remember?
So what is the meaning of fluorescent?
Fluorescent means it emits light. Okay.
Okay.
If we are telling that a device is fluorescent, means it will emit something. Okay. Emit light. Now these CFLs are such circuits, okay, which are used today. And why they are used? Why not bulbs? Because bulbs waste a lot of electricity in the form of heat. When we touch these bulbs, the old kind of bulbs, then we will see that it is too much heated up, but not the CFLs. Okay. And CFL is not wasting electricity in the part of heat one. It is emitting light. Okay. And what we
Sir,
require?
I have a doubt,
Yes.
sir. If appliance needs 5 ampere of 5.5 ampere of current,
Okay.
why can't we use a fuse of more power, sir? Like copper wire gives us very low amperes.
Now repeat your question. Let us go to that topic only. Repeat your question.
Sir, why can't we use like mostly copper wire gives us very low resistance, sir. Why can't
Yes.
we use aluminum in every fuse, sir, so that we can get more resistance and more amperes? Does more
Now
ampere dam?
this is the fuse and this is the thin. Now you are talking about this wire.
Yes, sir.
Okay.
If sir, if a appliance needs that specific amount of amperes, sir.
Suppose this needs 5.5 ampere. Okay.
Yes, sir.
Okay. This is
If
the
we give
appliance.
more than that ampere, more than
5.5 ampere, then it will damage.
yes, sir.
Now, I didn't understand your question. Again, you can repeat. You are asking about this wire, fuse
Yes.
wire that we
Yes,
are
sir.
using. Okay, what
Yes,
material
sir.
you feel should be used and what you think is being used?
Sir, I think mostly in the houses, copper is used, sir. But I
Yes,
think aluminium should be used because it
copper has lower
less
melting
resistance.
point. Not
Yes,
only the
sir.
resistance is required, lower melting point than you are telling about aluminum. Okay,
Yes, sir.
so this will damage more earlier than aluminum. If we are using copper wire, it will melt very
Yes, sir.
soon in comparison to aluminum. Okay, so
Yes,
we
sir.
want to have an element that will break itself or melt, okay, just
Yes, sir.
after 5.5 amps, isn't it?
Okay, sir.
So we are using copper because it is giving us better results than aluminum. Okay,
Yes, sir.
understood?
Yes, sir.
Okay. What topic we were discussing about?
Sir, we
CFL.
were CFL, sir.
CFL,
Compact
bulbs and
fluorescent.
CFL. Okay, here we were. Now we were using bulbs in the older days, है ना? Means in, we can say, like मेरे जमाने में हम लोग bulbs यही देखते थे. We used to see these yellow bulbs, okay, in our home, and they were much heated up than these CFLs. Okay, CFL modern जमाने का हो गया है ना? It is used today in each and every household. You can see, but these bulbs are not used anywhere. Okay,
Sir,
why? Ask.
why it was yellow?
Actually, these are not using the components that are used in CFL. Okay, they are having different properties. The bulbs that were used before and the CFLs that use presently, okay, this uses mercury. CFL uses mercury. Okay, and these bulbs used tungsten. You can say tungsten. Okay,
Okay.
in the bulb you are seeing like this fuse, and this is the bulb. So this is tungsten. Okay,
Okay.
so the property of tungsten was it had more resistance, and so a lot of electricity was wasted in the form of heat, and after it was heated up too much, then only it emitted light that we saw in yellowish shape. Okay, every element is having different kind of properties. Now this tungsten was giving such color, mercury gives us the color that we are seeing today, which is very much better than the before bulbs we are using. Clear?
Yes, sir.
Okay, now this CFL uses mercury, I told you. Now suppose there is a tube, okay, here. Inside this there is mercury, and also there is a plating, okay. Like here we are using a plating, okay. Like this. Now there are UV radiations. UV radiations, and this element, this layer is phosphor, okay. What this phosphor does, it absorbs these UV radiations. Okay, this phosphor absorbs the UV radiations emitted, okay, through this mercury, and this mercury is in the form of solid, liquid, or gas. What do you think?
Liquid, sir.
Gas. Okay, this mercury is in the form of gas. Okay, clear?
Yes,
Sir,
sir.
the plating is inside or outside?
Inside. Then only it can absorb, na? If it is outside, how it will absorb? Okay.
Yes.
Now, whenever we are using bulbs or mercury, CFL, whatever it may be, we are always seeing or checking the ISI mark. Are you aware of ISI? Have you ever heard this ISI?
No,
No.
sir.
ISI full form you can write it as Indian Standard Institution. Note it down. Indian Standard Institution. The helmet that we are using in two-wheelers is also having ISI mark. Have you heard about it, Naman?
Yes, sir. Sir,
Check the helmet.
IIC. Yes, sir.
Okay, ISI mark is there in the helmet also. That means it is authenticated one, or we can have belief on it that yes, it has been checked. It is legal. Okay, Indian Standard Institution. It has been checked by ISI. Okay, so we should use such appliances only in our home that is bearing ISI marks. Okay.
Okay, sir.
So all the things have ISI mark.
99% things will be having the ISI mark. Now the materials that are not constructed in India, they are coming from foreign. They may be having some other marks that we have to see. Okay.
Okay, sir.
Should I clear this page?
Yes, sir.
Now, have you heard about MCB? We are using this MCB in our home also. Nimisha?
Yes, sir. Yes, sir.
Tell me.
Sir, MCB's full form is miniature circuit breaker, sir.
Have you seen that practically in your home?
Yes, sir.
Okay, it is being used in home also, isn't it?
Yes, sir.
In the switchboard, you may be seeing there is one
Yes,
element
sir.
like this, and there is a switch like this, isn't it? This
Yes, sir.
can be moved upper side also. This is called MCB, miniature circuit breaker. Circuit breaker means it has the capacity to break the circuit, isn't it?
Yes, sir, I've seen.
Miniature circuit breaker means it can break the circuit, isn't it? And this may be on, and here it may be written off, or it may be vice versa. Here it may be written off, and here it may be written on also. Okay. Now we are using such MCBs today that are also fulfilling the criteria required for a fuse. Means there is no requirement of fuse if we are using a definite kind of MCBs. Okay. Whenever there will be a large current flowing any instant of time, this circuit will cut off automatically. Okay. And it uses magnetic effect. One of the effects of electric current is magnetic effect. We have already seen.
Yes, sir.
So whenever a large current flows, due to the circuit that we have made, the magnetic effect is also increased a lot, and it automatically switches off this MCB, or it comes down. Okay, and the circuit is like, if there is a circuit like this, we used to draw a switch here, and there is a resistive network, and here there may be a power supply, and this is connected like this. This is plus and this is minus. Now you can imagine this as MCB. Okay. Now whenever the current is much more than expected or required, so the MCB, this is the condition when the current is flowing in normal. Okay. Now if this switch is cut off from here and it is open, then the circuit is cut, current can't flow now. Okay. And the component that is here resistive is safe when there is a lot of current flowing at any instant of time. Is this clear to you both?
Yes, sir.
Yes, sir.
Should I clear this page?
Yes, sir.
Okay. Now we can use magnetic effect, as you have seen electric bells used. Electric bell. Whenever we switch on, suppose here there is a supply and here there is a bell. Okay, this is bell. Okay, whenever there is a break, then whenever the plus, minus, plus, and again minus will be there. Whenever we are switching on this, means we are connecting this. Okay, then the bell rings. The bell rings. Okay. Have you seen electric bell anywhere?
Yes, sir.
Yes, sir.
The call bell that we are having today was not in earlier time. The electric bells were there that were used practically. So this also uses magnetic effect. Magnetic effect of electric current is useful for electric bells also. It is also useful for, see there, if it is acting as a magnet, then what the magnet can do? If it is acting as magnet, it can attract the magnetic particles or iron particles, isn't it? Iron particles can be attracted. Iron particles. Okay, is it clear?
Yes, sir.
Now suppose we want to separate the magnetic particles from a mixture. There is a mixture, okay? It is having all the types of items, but there are magnetic items like iron particles also. Now this magnet will separate the magnetic, or you can say iron parts, and this magnet is not just a simple magnet that you have seen. There are very big magnets which are used. Have you seen practical use of magnets anywhere?
What, sir?
Have you gone to hospitals using CT scan and MRIs?
Yes, sir.
Yes, sir.
There is a large circular device in which a body is moved into.
Scanned.
Have you seen that?
Yes, sir.
No.
There also magnet is used. So magnet can be used in many purposes. So if you are told to tell any practical example of magnetic effect, then you can. And what is the full form of MRI? MRI. Magnetic resonance imaging. This I am giving you just for your information. Okay, magnetic resonance imaging. Image is taken, isn't it? One image is taken and given to you after MRI is done. Have you experienced that anytime, Naman? MRI?
No, sir.
Nimisha?
No, sir.
Okay, I have experienced. So there will be a sound continuously coming to your ears, and for about 15 to 20 minutes, it will be banging on your ears. Okay. After that, your body is moved out, and a report will be there in which, like X-ray, you are seeing X-ray. In X-ray,
Yes,
magnet
sir.
is not used. In CT scan, magnet is not used, but in MRI, magnet is used. Okay. So if you are told to give one example, you can say for MRI also, magnetic effect of electric current is used. Okay.
Sir, for what MRI is done?
MRI gives more resolution, more accuracy, and a much detailed report of whatever you are having from X-ray and CT scan. If there is a problem in any part of your body and X-ray and CT scan cannot give that report, okay, clearly, then MRI is done. MRI can give a more detailed report. There are many patients whose you can't find out what is the problem with it, but when MRI is done, you can easily find out what is the problem. Okay, and then only you can take any solution for that. And mostly it is in large hospital because it's very costly. It can't be used by simple persons. Okay, not by local doctors.
Okay.
So the magnetic effect is used by doctors also. Whenever a metallic part is there in your eyes by mistake, accidentally, if it goes into your eyes, how it can be separated? With the help of magnetic current, magnetic effect by doctors.
Sir, it doesn't harm our eyes.
Why it will harm? If there is something in your eyes and magnet here is your eye, magnet is not touching your eyes now, and there is one foreign material in this. Okay, and this is your eye. This is the foreign particle. Here is the magnet. Now when you are moving it closer here, it will attract this one and it will come out. That's all. You're not touching your eyes, no?
Yes, sir.
This particle, this foreign material is damaging your eyes. Okay, but to clear that only this magnet is used, isn't it, by doctors? So if you are told to give some practical incidents where this can be used, you can have hundreds of examples for that, isn't it?
Yes, sir.
Naman, did I give this quiz also yesterday on this chapter?
No, sir.
Nimisha,
Yes, sir.
I
You
think there were
gave,
two
sir,
quizzes
but you
yesterday, but at the same
yes,
time,
sir.
isn't
But
it?
you said I should give math one only, sir.
Yes, I told you to give maths only. Okay. Today the quiz is on which topic? Are you aware?
I am not aware, sir.
So let me see.
Nimisha,
I'm seeing, sir.
Naman, you can check my WhatsApp status also daily. Okay.
Okay,
I
sir.
add the quiz
Sir, it
schedule
is
also
on
daily.
electric current effects.
Huh?
Sir, it is on this chapter only.
On the same chapter, na?
Yeah.
Naman, can you see my status?
Yes, sir.
Can you see the quiz schedule there? For class 7 science, electric current and its effects, 40 questions and 60 minutes from 8 to 9. Are you available that time for the quiz?
Yes, sir.
Now, I also told you to prepare a notebook specially for quiz purpose.
Yes, sir.
Now, if there are 40 questions and you are not able to give any 2 or 3 questions or 5 questions, you have to note it down in your separate notebook, okay?
Okay, sir.
Or the questions in which you are having doubt, you can clarify it the next day whenever we are taking a class, okay?
Okay, sir.
Any more doubts in this chapter?
No, sir.
Go through the whole chapter again, revise it, and if any doubts are there, you can ask it tomorrow, okay?
Okay, sir.
Okay, sir.
We will end up now.
Goodbye, sir.
Bye-bye.